Hello, folks. This is Frank Gallagher. I'm with the Department of Landscape Architecture at Rutgers University and also the Urban Forestry Lab. I'm going to talk a little bit about climate change and what we can do to make it really concrete and real. I first came to know the folks over at the School of Conservation in the early 80s when I was working at both a naturalist at High Point State Park, and I was also on faculty at the Worth's campus of Uppsala College. And the place was really special. The School of Conservation had a unique set of folks, John and Jerry and Reggie and Randy, and then later on Bill. And they really had a strong connection to the land, and the footprints that they left on this landscape will be there for thousands of years. But let's be real about it, and the footprints of all peoples that lived on these lands are still there. They're sort of indelible, and they stand the test of time. For example, the Native Americans throughout North America used fire as a method for both game management and agriculture. And in fact, you can actually see some of those records in the ice core data that over the past 1,000 years, Native Americans were using fire, putting carbon dioxide into the atmosphere. And it actually increased the concentration of carbon dioxide in about 1,500 to 1,600. Most Native Americans, in fact, 90% of the population of the 60 million Native Americans were probably eliminated by smallpox brought over by the colonists. And as the population dwindled, the practice of fire dwindled, and the trees regrew. And as the trees regrew, they sequestered some of the carbon dioxide. Soon after that, in the 1700s, you start to see that spike up again. And that was primarily due to the next wave, the actual birth of the Industrial Revolution. In Sussex County, Sussex County was the seat of some of the most productive iron and zinc and even silver mines in the early colonial days. And so even the Andover iron mine was actually guarded by the Union soldiers during the Civil War because it was so valuable. But these mines, the forges needed wood as a fuel. They turned it into charcoal first and then burnt it as charcoal. But one forge would use about 3 acres of woods per day. So the woods we see here at Stoke State Forest and High Point State Forest, the High Point State Park, are really second, third generation forests. The change in sort of that philosophy happened about 100 years later when Teddy Roosevelt and his crew, including Gifford Pinchot, they recognized that the country was heading towards a timber famine. And so they started to protect lands at the national level. And that trend caught on even at the state level. And so Governor Stokes, shown here in the middle photograph, donated 500 acres of land, which would initiate what today is the 17,000 acres or so of Stoke State Forest. A few years later, a few decades later, the next Roosevelt president, Franklin Delano Roosevelt, would implement the New Deal and put people to work. And they created much of the infrastructure that you see in High Point and Stokes today. But one of the biggest accomplishments of the CCC for the 9 years that they were in existence was the planting of trees. The CCC actually planted somewhere in the neighborhood of 3.5 billion trees. In Stokes and somewhat in High Point, you can actually see the remnants of those plantings in the form of red pine stands, which dotted the landscape. My interest in sort of forest legacy didn't happen when I was first at High Point and Stokes, but rather when I was moved down to Liberty State Park. This Liberty State Park was a former railroad yard. And what amazed me when I got there was the transformation of the cinder and ash rail yard into an urban forest. And not only that it transformed, but how quickly it actually developed. And so we had good records of what the area looked like dating back to the dissolution of the Central Railroad of New Jersey in 1969. And then we could plot out basically the vegetative communities over time and see how they developed. And so we found a lot of really good information about plant productivity, plant diversity over 40 or so years of the development of the park. And as we dove deeper into the data, one of the things that we actually observed was that there wasn't this gradual linear progression, but rather things would go along at a pretty steady rate, and then all of a sudden something would change. The top graph shows the response of the vegetative productivity to the soil metal load. Basically, the x-axis is the soil metal load, and higher numbers are greater soil metal load or contaminant load. And what it shows you is that things go along pretty well, and plants are able to tolerate some level of contamination. And then at some point, things change and they say, no, thank you, and productivity drops down. The bottom graph shows you that this is a graph of leaf area cover, basically canopy cover in the urban forest of Liberty State Park. And what it's showing you is that at 3 out of the 4 sites, things are going along fairly well, fairly steady. And then, interestingly, in 2012, things drop out. We all know that Hurricane Sandy hit the area pretty heavy in 2012 and caused a lot of damage. And so we expected the canopy cover to drop out due to physical damage. But what we did not expect was that it would not recover. And we haven't seen that to this date, that it has not recovered. And so we started to say, well, how can we really examine this phenomena? And we started to look at tree cores. These are cores from Betula papifolia, which is the gray birch. And you can see the pith on both of these is right about there and right about there. The trees grow for a period of time at a fairly decent clip, and then boom, growth really slows down. And it slows down right after Sandy. And the interesting part, now these are taken from healthy trees that in fact have more opening in the canopy than they did in the past. So growth should pick up pretty rapidly, but something structurally has changed. My feeling is that it could be because the soils were exposed to brackish water from the storm, that the microfloral community that used to exist at the rail yard no longer exists, and something is fundamentally changed. So we start to thinking about that and say, well, this is a special situation where you have an urban, novel community that is really stressed. Well, what about other communities? And my thoughts went immediately to Stokes at the High Point, and to those red pines we talked about with the CCC planting. Piney Point there on the left actually was planted a little later by Boy Scouts in the 1950s, but still, you have almost 80 years of records in these pine trees. And so we start to take, in addition to that, the interesting part about red pines is that it is at the southern extreme of its range here in New Jersey. And in fact, the stands that we see today were planted by the CCCs. They probably would not be here naturally. And so since they're at the very southern end of their functional range, they're also in somewhat of a stress condition and will probably show signs of climate change more rapidly than something, say, in Ontario, where it's in the middle part of their range. And so we began to take apart some of these. We have not taken apart, but actually just pull cores from some of those trees, and we just started to look at these data. So this is very early data, and there's no conclusions yet. But the idea that there is a breakpoint at which the trends in growth change, I think, are starting to become evident even in this early data. Now we do the math to make sure that we compensate for the size of the tree and the site index. And so these values that you see here in the graph on the lower part of the slide represent pure growth in terms of wood put on in a year. And if you look at it, back here, there's a certain trend that, it has a lot of variation, but over here, the trend is actually much different. And somewhere around here, we see that there's a change. And so that change around 2000, a year 2000 or so, represents what may be another one of these threshold model growth rates. And so red pine may be, again, changing and migrating north much faster than most models originally predicted. And what's nice about this species is that we have those data that represents what the norm should be from the northern part of its range. This happens to be from a study that was done in Ontario, Canada, looking at the different site indices for the growth of red pine and showing you what the norm basically is. And so by comparing these two sets of data, we can see how fast the lower part of the range is actually moving. And then the final step will be to take this and look at climatological data and try to do some correlation between the changes that we've seen in the weather and climate patterns to the growth rates over longer periods of time. One of the things that we noticed, and this happens to be data that we were looking at from Liberty State Park, is that one of the high correlates was to the dry spells in the summer. In the last 10 or 15 years, our summer dry spells have gotten more intense. And with that intensity, the soil moisture level has dropped out quite a bit. And it actually has caused some false growth rings in the tree cores that we've taken, because the growth slows down so much in the middle of the summer and then picks up again in the fall when water becomes available. And so it's these types of trends that we're looking for species all over, that we can, so that we can model more effectively how climate change will impact the vegetative community structure here in the middle part of the eastern coast. And what I really enjoy about using tree rings and studying vegetative structure is that you don't have to be a PhD and scientist to look at this and to make climate change really concrete. I mean, there is a plethora of supplemental environmental education materials out there that you can take, and we'll post the tree cores so that you can kind of look at the tree cores from Stoke State Forest with their locations, so you can actually map them out and begin to look at growth trends in the tree cores, just as you would in a tree cookie shown here. So the next speaker, Dave Robinson, from the state climatologist from Rutgers, will actually talk about some of the data that's available, from climate data that's available, and so that we can begin to make those correlations at any level. So those are some of my thoughts on how to make climate change real to students from anywhere from the fourth grade on up, and how to use data that is local, that will say, hey, this is affecting my home too. So thanks for listening, and I hope to see you soon.